What if I told you that long before humanity even dreamed of reaching the stars, something or someone might have already made the first incredible leap between galaxies? The idea of traveling beyond our own Milky Way feels like science fiction, but what if the universe's first intergalactic voyage wasn't just possible, but already happened? Think about it, we've spent decades perfecting rockets, telescopes, and warp drive theories, all to scratch the surface of space travel. Yet, out there in the cosmic dark, ancient clues might be hiding, whispering stories of journeys more epic than anything we've ever imagined. From the moment we first looked up at the night sky, humans have been obsessed with the unknown. Every civilization has spun myths about celestial wanderers, gods riding chariots of fire, star-bound heroes, even entire cities rising into the heavens. But these aren't just stories, they're echoes of a deeper truth. We've always sensed that the universe is meant to be explored, and now science is catching up to that instinct. Astrophysicists, cosmologists, and even philosophers are piecing together theories so daring, they rewrite what we thought was possible. Some believe black holes could be portals. Others argue that advanced civilizations might have left behind cosmic breadcrumbs, megastructures, energy signatures, even entire highways carved through space-time. And then there's the wildest idea of all. What if we're not the first to dream of crossing that unimaginable void? That's exactly what we're diving into today, 30 of the most mind-bending theories about how the universe's first intergalactic travelers could have done it. We're talking about civilizations so advanced, their technology might as well be magic, or natural phenomena so bizarre, they defy the laws of physics as we know them. Maybe it was a rogue planet, flung across the cosmos by a dying star, or an alien species that cracked the code of faster-than-light travel millions of years before Earth even formed. Whatever the truth, one thing's for sure, the evidence or the lack of it is hiding in plain sight, so buckle up, because by the end of this journey, you'll never look at the night sky the same way again. Imagine a civilization so advanced, they mastered the stars long before Earth's first microbes even stirred in the primordial soup. This is the heart of theory, one, the idea that ancient alien visitors may have cracked intergalactic travel billions of years ago, leaving behind whispers of their journeys in our own cosmic backyard. Ancient astronaut theorists point to bizarre, unexplained artifacts and structures scattered across our planet as potential evidence. Take, for instance, the Antikythera mechanism, a 2,000-year-old device so complex, it's been called the world's first analog computer. How could such advanced engineering exist in ancient Greece? Or consider the pyramids of Giza, aligned with eerie precision to celestial bodies, their construction methods still debated by modern engineers. But the clues might go even deeper. In the 1960s, Soviet scientists discovered microscopic tungsten filaments in Siberian rock layers dating back hundreds of millions of years, materials that, under natural conditions, shouldn't exist there. Could these be remnants of ancient alien technology, long buried by time? Some researchers even speculate about the famous WOW signal, a mysterious radio burst detected in 1877 that matched the expected signature of an artificial transmission. Though never repeated, its precision has fueled theories that it might have been a distant beacon or a stray signal from a long-gone interstellar traveler. Then there's the cosmic perspective. The universe is 13.8 billion years old, while human civilization is a mere blip in that timeline. Statistically, other intelligent species could have risen and fallen countless times before us. If even one developed the means to cross galaxies, where might their relics be hiding? Some propose they're embedded in our myths. The Sumerians wrote of the Anunnaki, gods who descended from the heavens. The Dogon tribe of Mali, with no access to modern telescopes, somehow knew about Sirius B, a star invisible to the naked eye. Are these just coincidences or fragments of an older, interstellar truth? The most tantalizing possibility, we might not need to dig through ancient ruins to find proof. Astronomers scanning the cosmos today have spotted strange anomalies, like Oumuamua, the first known interstellar object to pass through our solar system. Its unusual acceleration and shape sparked debates. Was it a rogue asteroid, or something more deliberate? If advanced civilizations did traverse galaxies, their greatest monuments might not be on planets at all, but drifting between the stars' silent ships, long abandoned, waiting to be found. Forget spaceships or warp drives. What if the universe itself provided the ultimate shortcut? Theory 2 takes us into the mind-bending realm of natural wormholes, cosmic tunnels that could have ferried life between galaxies without a single engine or fuel source. Einstein's equations predicted these structures, called Einstein-Rosen bridges, over a century ago. Picture space-time as a stretched bedsheet, with massive objects like stars creating dips in the fabric. Now imagine pinching two distant sections of that sheet together until they touch. That's the essence of a wormhole, a theoretical bridge where the entry and exit could be light years apart, turning an impossible journey into a stroll through a cosmic backdoor. But here's where it gets wild. While we've never observed a stable wormhole, quantum physics suggests tiny versions might flicker in and out of existence constantly at microscopic scales. Some physicists speculate that in the early universe, extreme conditions like the searing heat of the Big Bang could have stretched these quantum wormholes into macroscopic highways. Entire star systems or even pockets of life might have been swept through them like leaves in a cosmic current. Imagine a planet orbiting a dying star, only to be flung through a sudden space-time rift and deposited in another galaxy entirely. No technology required, just the universe's own chaotic physics playing ferryman. The implications are staggering. If wormholes exist naturally, they could explain why we haven't found clear evidence of alien megastructures or ships. Advanced civilizations wouldn't need to build them, they'd just need to find and stabilize them. Russian astrophysicist Nikolai Kardashev, who theorized about civilization types based on energy use, suggested a Type 3 civilization, one capable of harnessing galactic-scale power, might treat wormholes like subway lines. But what if nature beat them to it? Consider the eerie case of hypervelocity stars. These rogue celestial bodies scream through space at speeds so extreme, they shouldn't exist under normal galactic physics. Some, like Hezio 4375439, race at nearly 2 million miles per hour, fast enough to escape the Milky Way's gravity. Astronomers blame black hole interactions, but what if a handful were spat out the other side of a wormhole? Even more provocative, certain extremophile bacteria on Earth survive conditions akin to interstellar space. Could microscopic life have hitchhiked through these tunnels, seeding itself across galaxies like cosmic pollen? Critics argue that traversable wormholes would require exotic matter with negative energy to stay open, a substance we've never observed, yet mysteries persist. The Fermi paradox asks, where is everybody? Maybe the answer isn't about distance, but about portals we're just beginning to fathom. If ancient wormholes once littered the cosmos like abandoned bridges, the first intergalactic travelers might not have been explorers at all, but passengers on the universe's own unfathomable transit system. What if the fastest way to cross a galaxy wasn't moving at all? Theory 3 plunges us into the quantum realm, where the rules of distance and time unravel, and the key to intergalactic travel might lie in the spooky connections between particles. This is the world of quantum entanglement, a phenomenon so bizarre, even Einstein called it spooky action at a distance. Here's how it works. When two particles become entangled, they're linked in ways that defy classical physics. Change the state of one, no matter how far apart they are, and the other instantly mirrors it, as if they're dancing in perfect sync across the cosmos. Scientists have already harnessed this phenomenon for quantum teleportation in labs. In 2017, Chinese researchers teleported a photon from Earth to a satellite orbiting 300 miles above, breaking the record for the longest distance quantum teleportation. While we're not beaming humans yet, the principle is tantalizing. Imagine scaling this up, an entangled particle pair, with one left on Earth and the other carried to another galaxy. Manipulate the local particle, and its twin responds instantaneously, effectively teleporting information, or perhaps one day, matter across unimaginable voids. No lightspeed limits, no wormhole uncertainties, just a cosmic loophole in the fabric of reality itself. But could entanglement truly enable physical travel? Some theorists speculate about quantum swap teleportation, where entangled particles act as a bridge. A traveler's molecular structure could be scanned, transmitted via entanglement, and reconstructed at the destination using local raw materials, like faxing yourself across the universe. The catch: current physics says we need a receiver at both ends, implying someone, or something, already planted the quantum groundwork in distant galaxies. That raises a chilling possibility. If entanglement teleportation is real, the first intergalactic travelers might have left their calling cards hidden in the quantum fabric, waiting for us to decipher the signal. The universe might already be whispering proof. Astronomers have detected strange correlations between distant quasars' galactic cores blazing with light, where measurements of one seem to influence another millions of light years away. Could these be natural entanglement networks, cosmic highways we've yet to map? Or consider dark matter's elusive grip on galaxies. What if it's not just invisible mass, but a quantum web stitching the universe together? The answers might lie in experiments like NASA's upcoming Cold Atom Lab, which will study entanglement in microgravity, pushing the boundaries of what we know about quantum links in space. Skeptics argue that entanglement can't transfer matter or energy, only information, yet every breakthrough begins with impossibility. If ancient civilizations mastered quantum tech, their greatest legacy might not be monuments or machines, but the entangled particles they scattered like breadcrumbs, a trail we're only now learning to follow. The universe's first intergalactic journey might not have been a voyage at all, but a single, spooky step into the quantum unknown. Picture harnessing not just a star's power, but an entire network of them, enough energy to fling a civilization clear across the cosmic void. This is Theory 4's staggering premise, that advanced beings could turn stars themselves into engines, using megastructures so vast, they defy comprehension. Enter the Dyson sphere, a hypothetical shell built around a star to capture nearly all its radiant energy. First proposed by physicist Freeman Dyson in 1960, the concept was meant as a thought experiment. But for a civilization reaching Type 3 status on the Kardashev scale, one capable of utilizing energy at galactic scales, this could be more than theory. It could be the ultimate propulsion system. Now, imagine taking that idea even further. Instead of passively collecting energy, what if a civilization could manipulate multiple Dyson spheres to create synchronized gravitational forces? By carefully positioning these star-encasing structures around a central hub, they might generate a slingshot effect, a series of controlled stellar explosions, or directed energy bursts acting like cosmic push points. Recent simulations by astrophysicists at the University of California suggest that such a stellar engine could accelerate a massive object to a fraction of light speed over millennia. But for intergalactic travel, the real breakthrough would come from linking several star systems together, creating a chain reaction of propulsion events. Each star's energy adds another wave to the cosmic surf, riding the craft toward another galaxy. Evidence might already exist in the patterns of distant starlight. Astronomers have cataloged stars with bizarre, periodic dimming like KZ 8462852, nicknamed Tabby's star, that some speculate could indicate megastructures in progress. Then there's the peculiar case of quasars emitting energy in directed jets, natural phenomena resembling the very propulsion method a Dyson slingshot might mimic. If an ancient civilization mastered this technology, Remnants could linger in the form of oddly clustered neutron stars or black holes, arranged like waypoints on an interstellar highway. The challenges are mind-boggling, of course. Stabilizing a Dyson sphere requires materials stronger than any known element, and coordinating multiple stars demands precision beyond our current math. Yet if such a system was achieved, the rewards would be universe-altering. A single network could launch probes, or even entire populations toward Andromeda or beyond, riding waves of harnessed starlight. The cosmos might be littered with these dormant stellar catapults, their builders long gone, but their engineering silently waiting for the next curious species to unlock their secrets. Beneath the visible universe lies an invisible web, stretching across billions of light-years like ghostly scaffolding, and it might be the ultimate roadmap for intergalactic travel. Theory 5 pulls back the curtain on dark matter, the mysterious substance making up roughly 85% of the universe's mass. We can't see it, we can't touch it, yet its gravitational grip shapes galaxies and clusters into vast cosmic filaments. Some researchers now propose these filaments aren't just structural, they could be highways, navigated by civilizations who learned to ride the unseen currents of the cosmos. Think of the universe as an ocean. Ordinary matter, the stars, planets, and dust we see, is just froth on the waves. Dark matter is the deep current beneath, flowing in predictable rivers between galaxies. Advanced beings might not need rockets or wormholes if they could harness these currents, using dark matter's gravitational pull as a natural propulsion system. It sounds like fantasy, but the math is compelling. Simulations at the Harvard-Smithsonian Center for Astrophysics show how objects caught in dark matter streams could travel hundreds of times faster than conventional spacecraft, accelerated by the invisible tides. The evidence might be hidden in the odd behavior of certain galaxies. Take the Bullet cluster, where two galaxy clusters collided, their visible gas slowed by friction, but their dark matter components, detected via gravitational lensing, sailed right through each other like ghosts. If matter barely interacts with these dark currents, a ship designed to surf them could theoretically avoid the crushing g-forces of traditional acceleration. Imagine a vessel wrapped in a dark matter sail, catching the cosmic wind between galaxies without burning a drop of fuel. Even more intriguing are the so-called dark galaxies, objects like Dragonfly 44, which emits almost no light but weighs as much as the Milky Way. These shadowy structures could be way stations or fueling depots, their dense dark matter cores acting as gravitational anchors for travelers. Or consider the bizarre, fast radio bursts from deep space. Some last mere milliseconds but pack more energy than the sun emits in months. Could these be navigational beacons, pulsing along dark matter thoroughfares? Critics argue we still don't understand dark matter's true nature, let alone how to manipulate it. Yet every mystery invites bold speculation. If ancient explorers once traversed these hidden roads, their passage might be written in gravitational waves we're just learning to read, or in the peculiar orbits of dwarf galaxies, drifting like buoys marking an unseen sea lane. The universe's first great voyage may not have been through space, but with it, riding the dark rivers we're only beginning to map. What if the secret to crossing galaxies isn't speed, but time itself? Theory 6 flips the script on intergalactic travel with a radical proposition. Civilizations might not need faster-than-light engines if they're willing to let physics do the heavy lifting. Enter the concept of generation, ships' massive arcs designed to sustain populations across millennia, supercharged by Einstein's time dilation. Here's how it works. As a ship approaches light speed, time slows down for everyone aboard relative to the outside universe. At 99.9% light speed, a 1,000-year journey for stationary observers could feel like mere decades to the travelers. Suddenly, a trip to Andromeda, 2.5 million light-years away, becomes survivable for a determined crew. But this isn't just theoretical. Scientists have already observed time dilation in action. Atomic clocks on GPS satellites, moving faster than Earth's surface, tick measurably slower just as relativity predicts. Scale this up to near light speeds, and the effects become staggering. A civilization launching a ship toward another galaxy might witness their descendants arriving centuries later, while millions of years pass in the wider cosmos. The real breakthrough, combining this with suspended animation or genetic engineering to minimize resource use. Imagine a vessel where crews cycle through hibernation, their biology slowed to match the ship's relativistic time flow. Entire generations could live, die, and be born in transit, with the ship's AI navigating the voids between stars. Evidence might already lurk in our own cosmic neighborhood. The mysterious dimming of stars like VVVW-08, which faded by 97% for months, could hint at colossal structures obscuring their light. Some astronomers speculate these might be incomplete Dyson swarms, but what if they're abandoned generation ships, drifting after their original crews vanished? Even more provocative, certain globular clusters orbiting the Milky Way contain stars with chemical signatures suggesting they originated in other galaxies. Could these be the remnants of ancient ark ships that arrived billions of years ago, their passengers long dispersed? Critics argue that sustaining closed ecosystems for millennia is implausible, yet nature already provides blueprints. Earth's tardigrades survive vacuum and radiation, while certain bacteria revive after 250 million years trapped in salt crystals. Pair these with advanced recycling systems, and a generation ship becomes less fantasy, more inevitability. The universe might be teeming with these slow-motion voyagers, their journeys invisible to us because they are lost in the crawl of cosmic time. If time dilation ships exist, the greatest intergalactic travelers wouldn't be the ones who arrived quickly, but the ones patient enough to let relativity carry them. What if the ultimate form of space travel required no ship at all, just the power of thought itself? Theory 7 takes us into the realm of consciousness transfer, where minds could traverse galaxies untethered from fragile biological bodies. This isn't just sci-fi speculation. Cutting-edge neuroscience and quantum physics are beginning to flirt with the idea that consciousness might exist independently of physical form. Imagine a civilization so advanced, they crack the code of the mind, digitizing thoughts and memories into pure information. Those packets of self-awareness could then be beamed across the cosmos at light speed, riding laser pulses or quantum signals to waiting receivers in distant galaxies. The groundwork for this is already being laid today. Scientists have successfully encoded simple memories in lab rats, transferring them between brains. Projects like Neuralink aim to merge human cognition with machines, while quantum experiments suggest that information might be entangled across space instantaneously. Now scale this up, an entire civilization's collective consciousness, distilled into data streams and transmitted like cosmic radio waves. The implications are staggering. No fuel, no life support, just pure thought, traveling unfettered through the void. But where's the proof? Some point to the baffling phenomenon of gamma-ray bursts, intense flashes of energy from deep space with no clear natural explanation. A handful of these bursts exhibit patterns eerily reminiscent of encoded information, like pulses in a Morse code we can't yet decipher. Then there's the enigmatic LGM-1 signal, originally mistaken for an extraterrestrial beacon, which some theorists speculate could have been a fragment of a much larger data transmission. If advanced beings mastered consciousness transfer, their greatest monuments might not be physical at all, but swirling clouds of energy in deep space server farms for uploaded minds. Skeptics argue that consciousness is too poorly understood to be digitized, let alone transmitted. Yet consider this: if another species solved the puzzle first, their explorers might already be here, not as green-skinned aliens, but as whispers in our radio static or anomalies in our particle colliders. The universe's first intergalactic travelers could be all around us. their thoughts woven into the fabric of reality itself, waiting for us to learn their language. Black holes, cosmic monsters so powerful, not even light escapes their grip. But what if these terrifying voids aren't just traps but gateways? Theory 8 plunges us into one of astrophysics' most provocative ideas, that some black holes might be nature's ultimate shortcuts, ferrying matter, or even intrepid travelers, clear across the universe. The math is already whispering tantalizing possibilities. Einstein's equations suggest that at the heart of a spinning black hole, the singularity might not be a point, but a ring, a so-called Kerr singularity. Pass through it and you could emerge somewhere entirely different, like stepping through a cosmic turnstile. Recent simulations from the University of Massachusetts have added fuel to the fire. Their models show that under specific conditions, a black hole's extreme gravity could warp spacetime into a tunnel-like structure, connecting distant regions of the cosmos. Think of it like a whirlpool in the ocean. If you ride the currents just right, you might get sucked into the vortex only to be spat out in another part of the sea entirely. The catch: surviving the trip would require navigating the black hole's crushing tidal forces and lethal radiation, but for a civilization with technology advanced enough to harness exotic matter or manipulate spacetime itself, it might not be impossible. Clues might already lurk in the skies. Take the bizarre behavior of quasars, supermassive black holes at galaxy cores that blast out jets of energy. Some, like quasar 3C273, eject material at nearly light speed in perfectly aligned beams. Astrophysicists have long debated why these jets stay so focused over millions of years. Could they be evidence of a stabilized gateway, funneling energy, or something else between galaxies? Even stranger are the rare, orphan black holes drifting between stars, untethered to any galaxy. These rogues might be relics of ancient cosmic transit, their original gateways long vanished. Then there's the mystery of Hawking radiation. The late Stephen Hawking theorized black holes slowly leak energy, evaporating over eons, but some physicists now speculate this radiation could carry imprints of anything that fell in, like a scrambled message from the other side. If true, decoding it might reveal whether black holes are one-way traps or secret corridors. The James Webb Space Telescope's recent detection of unexpectedly ancient supermassive black holes adds another wrinkle. How did they grow so massive, so fast? One controversial answer: they're not just cosmic vacuums, but recycling centers, funneling matter from elsewhere in the universe. Skeptics argue that even if black hole gateways exist, the energies required to traverse them are unfathomable. Yet nature is full of surprises. Consider extremophiles on Earth, organisms thriving in boiling vents or crushing ocean depths. Life finds a way in the harshest places. If a civilization cracked the physics of singularity navigation, their greatest legacy might be hidden in plain sight. The supermassive black holes anchoring every galaxy, silent sentinels of an interstellar subway system we're just beginning to imagine. The universe's first voyagers might not have crossed the void, they could have stepped through it. We think of life as we know it, carbon-based, water-dependent, bound to planets, but what if the universe's first intergalactic travelers weren't solid at all? Theory 9 shatters our terrestrial biases with an electrifying possibility: plasma-based life forms, beings of pure energy thriving in the searing hearts of stars, riding cosmic currents between galaxies like surfers on a solar wave. This isn't just wild speculation. The physics of plasma, the fourth state of matter, makes it startlingly plausible. Picture a creature not of flesh and bone, but of ionized particles, structured by magnetic fields and sustained by the unimaginable energies of stellar cores. To them, the vacuum between galaxies wouldn't be a barrier, but a highway. Consider the behavior of solar prominences, those colossal loops of plasma arcing from the sun's surface. They twist and reform in ways that eerily mimic organic movement, as if responding to some unseen intelligence. Into the 19, researchers at the University of California discovered plasma can self-organize under certain conditions, even exhibiting lifelike behaviors such as replication and communication. Now imagine this same principle scaled up to sentience within a star's swirling depths. Such beings wouldn't need ships, they might reshape their own bodies into electromagnetic sails, catching the solar winds that stream between stars. The evidence could be hiding in plain sight. Astronomers have detected bizarre plasma filaments stretching tens of thousands of light years between galaxy clusters, like cosmic power lines. Some, like the one linking Abell 402 and Abell 54, pulse with unexplained regularity. Then there's the mystery of fast radio bursts, those millisecond energy pulses from deep space. While most assume natural origins, a handful repeat with near mathematical precision. Could these be the equivalent of plasma life conversations, or even navigational beacons etched into the fabric of space itself? Even more provocative are the anomalies within our own sun. The Parker Solar Probe recently recorded switchbacks, sudden reversals in the sun's magnetic field that defy conventional models. Some plasma physicists speculate these could be signatures of complex, self-sustaining structures within the star's plasma soup. If true, it wouldn't just redefine life, it would suggest the universe's first intergalactic migrants might still be here, dancing in the coronas of stars we've yet to study closely. The implications rewrite the rules of astrobiology. If plasma life exists, the Drake equation, which estimates intelligent civilizations, might need an entire new variable. Stars wouldn't just be engines of light, but potential ecosystems, and the greatest voyages in cosmic history might have been undertaken not by metal ships, but by beings who learned to weave themselves into the very storms that birth galaxies. The night sky's true explorers could be all around us, invisible to our eyes, but humming just beneath the surface of every burning star. Across the cosmos, hidden in plain sight, there might be a web more intricate than anything we've imagined, a living, growing network stretching between galaxies like the mycelial threads of a cosmic fungus. Theory 10 proposes something extraordinary, that the universe itself could host a vast biological superhighway, a galactic mycelium network capable of transporting life or even advanced technology between the stars. It sounds like science fiction, but the parallels in nature are impossible to ignore. On Earth, mycelium, the underground fungal network, acts as a planet-wide communication and nutrient distribution system, linking trees and plants across continents in what scientists call the Wood Wide Web. Now scale that idea up to intergalactic proportions. The foundation for this theory lies in the bizarre resilience of extremophiles. Certain fungi, like Cladosporium sphaerospermum, have survived months on the outside of the International Space Station, enduring vacuum, radiation, and temperature swings that would kill most organisms. Even more astonishing, experiments show fungal spores can survive the intense pressures and accelerations of hypervelocity impacts like those of an asteroid strike and still remain viable. If fungal life can hitchhike between planets, why not between galaxies? Some astrobiologists speculate that networks of fungal-like organisms could span interstellar dust clouds, their tendrils feeding on cosmic radiation and molecular hydrogen, knitting themselves into vast, living bridges across the void. But the real mind-bender comes when we consider how such a network might be manipulated. Advanced civilizations, or even the network itself, could use these biological pathways to transport information or matter. Imagine mycelial nodes acting like organic quantum computers, storing data in the arrangement of their hyphae. Civilizations might tap into this system, sending encoded packets of DNA or nanotech through spore-like capsules that travel the network's filaments. Recent discoveries lend eerie weight to the idea. The Atacama Desert's dark microbiome, a community of microbes thriving in hyper-arid conditions, contains DNA sequences unlike anything in known databases. Could these be fragments of a larger, cosmic biological web? Then there's the enigma of panspermia with purpose, most theories assume life spreads randomly via comets or asteroids. But what if it's deliberate? The mysterious Oumuamua object, with its unusual acceleration and shape, sparked debates about artificial origins. Less discussed were the traces of organic molecules found in its wake. While inconclusive, they raise a provocative question: could some interstellar objects be fungal seeds, dispatched to colonize new galaxies? Even more tantalizing are the unexplained patterns in cosmic microwave background radiation. Some theorists suggest they resemble the branching structures of mycelium, as if we're glimpsing the shadow of a universe-spanning organism. Critics argue that maintaining such a network across light years defies known biology, yet nature constantly surprises us. Slime mold simple fungi can solve complex mazes and simulate Tokyo's rail network with uncanny accuracy, despite having no nervous system. If terrestrial fungi can think in ways we're only beginning to understand, what might a billion-year-old galactic network achieve? The universe's first travelers might not have been explorers at all, but spores drifting on the cosmic breeze, weaving a living bridge between the stars. And if that's true, the greatest discovery awaiting us might not be alien ships, but the mycelial tendrils already threading through the cracks of reality, whispering secrets we're just learning to hear. Empty space isn't really empty. That's the startling revelation at the heart of Theory 11. What if the void between stars holds an almost infinite reservoir of energy, just waiting to be tapped? This is the promise of quantum vacuum propulsion, a theoretical system where spacecraft could ride the very fabric of reality itself. According to quantum mechanics, even in a perfect vacuum, particles flicker in and out of existence in a chaotic dance called zero-point energy. These virtual particles borrow energy from nowhere, existing for mere fractions of a second before vanishing again. But for a civilization advanced enough to grasp them, this quantum foam could be the ultimate fuel source, unlimited, omnipresent, and free from the constraints of traditional physics. The math behind this idea traces back to the Casimir effect, a phenomenon first demonstrated in 1948. When two metal plates are placed incredibly close together in a vacuum, they're subtly pushed toward each other by the pressure of virtual particles outside the gap. This proves that zero-point energy isn't just theoretical, it exerts real, measurable force. Now, imagine scaling this effect with metamaterials or quantum manipulators to create asymmetric thrust. Certain designs, like the hypothetical quantum vacuum thruster, suggest that shaping spacetime at microscopic levels could generate propulsion without expelling mass. Instead of burning fuel, such an engine would effectively push off the quantum fluctuations themselves, like a surfer catching waves in an invisible sea. Evidence for its plausibility comes from unexpected corners of science. NASA EagleWorks lab famously tested the controversial M-Drive, a device that appeared to produce thrust without propellant. Though later debunked, the experiment sparked serious discussions about quantum vacuum interactions. More compelling are recent breakthroughs in quantum field manipulation. In 2021, researchers at Chalmers University demonstrated how superconducting circuits could temporarily trap virtual photons, a step toward harnessing zero-point energy. If scaled, this could lead to engines that don't just defy our current understanding of physics, they'd rewrite the rules entirely. The implications for intergalactic travel are staggering. A ship powered by zero-point energy wouldn't need to carry fuel, freeing it from the tyranny of the rocket equation. It could accelerate continuously, reaching relativistic speeds without the need for massive fuel reserves. Some models even suggest such propulsion might allow for manipulations of spacetime itself, creating localized warps that sidestep light speed limits. The universe's first travelers might have left behind subtle clues, anomalous energy signatures around ancient neutron stars, or unexplained ripples in the quantum vacuum that echo like footprints across the cosmos. Of course, skeptics highlight the monumental hurdles. Extracting usable energy from the vacuum remains beyond our grasp, and the energies involved are typically vanishingly small. Yet history shows that every breakthrough once seemed impossible. If an ancient civilization cracked the quantum code, their voyages might have left no physical traces, just faint murmurs in the fabric of space, whispers we're only now learning to hear. The greatest journeys in cosmic history could have been propelled not by fire or light, but by the boundless energy hidden in the emptiness between atoms. The fabric of reality might be threaded with invisible highway structures so unimaginably dense, a single inch would outweigh Mount Everest. These are cosmic strings, theoretical remnants of the early universe, and Theory 12 proposes they could be the ultimate interstellar freeways. Born in the first fractions of a second after the Big Bang, these filaments of pure space-time curvature are thought to stretch across the entire cosmos, thinner than an atom but under unimaginable tension. For a civilization advanced enough to find and harness them, surfing these strings could mean crossing galaxies in the blink of an eye, no engines required, just the universe's own primordial architecture. Picture a cosmic string as a guitar string vibrating at the scale of the universe. According to physicists like Alexander Vilenkin, these strings would carry incredible energy, enough that plucking one might create gravitational waves detectable across space. Now imagine a ship designed to latch onto that vibration, riding it like a surfer catching a wave. The math gets wilder, because cosmic strings warp space-time around them. Traveling parallel to one could effectively compress the distance ahead while stretching what's behind, creating a natural warp drive effect. You wouldn't be moving faster than light, you'd be cheating distance itself. The clues might already be written in the sky. Astronomers have spotted bizarre, perfectly linear arrangements of galaxies, like the Hercules Corona Borealis Great Wall, that defy conventional models of cosmic structure. Some theorists suggest these could be shadows of hidden cosmic strings, their gravity subtly sculpting matter over eons. Even stranger are certain gravitational lensing events where light bends in ways that can't be explained by visible mass alone. Could invisible strings be the culprits? Then there's the tantalizing case of paired quasars with eerily similar properties, but billions of light-years apart. If cosmic strings thread the universe, they might have once connected these objects before stretching beyond recognition. But how would surfing actually work? One radical proposal involves string shaving, using focused energy to trim microscopic portions of the string, converting its colossal tension into thrust. Alternatively, a ship might generate a localized magnetic field strong enough to stick to the string's electromagnetic wake. The energy costs would be astronomical, but so are the rewards, a network linking every corner of the cosmos. If ancient travelers mastered this, their legacy might be hidden in the delicate gravitational ripples we're only now detecting with observatories like LIGO. Critics argue cosmic strings remain hypothetical, with no definitive observational proof, yet their potential is too compelling to ignore. Like spiders sensing vibrations in their webs, an advanced species might have learned to read the hum of these cosmic threads, turning the universe's scars into the ultimate transit system. The greatest voyage in history could have been less about crossing space and more about learning to dance on the strings that stitch it together. What if the first beings to cross the cosmos weren't creatures of flesh, or machines of metal but fleeting thoughts, materialized from the chaos of the universe itself? Theory 13 plunges us into one of physics' most mind-bending concepts, the Boltzmann brain, a self-aware entity that spontaneously forms from random quantum fluctuations. These hypothetical consciousnesses, named after 19th-century physicist Ludwig Boltzmann, arise from sheer statistical probability in an infinite universe. Given enough time, even the most improbable events become inevitable, including the emergence of a fully formed, thinking mind from the void. Now stretch this idea further. What if some of these ephemeral intelligences didn't just flicker into existence, but learn to navigate the fabric of reality before dissolving back into the cosmic noise. The math behind this is as haunting as it is elegant. In an eternal universe, every possible configuration of matter will eventually occur purely by chance, including brains identical to yours, complete with false memories of reading this script. But the real twist comes when we consider scale. Quantum foam, the seething, probabilistic foundation of reality, constantly births particles and energy from nothingness. Most vanish instantly, but in an infinite cosmos, some fluctuations might achieve not just coherence, but consciousness, advanced enough to perceive their own existence. These Boltzmann explorers could exploit quantum tunneling to jump across space-time, appearing near distant stars before vanishing like echoes. Their journeys wouldn't require ships or energy, just the universe's own random generosity. Clues might lurk in the anomalies of deep space observations. Certain gamma-ray bursts exhibit patterns too structured to easily dismiss as natural, like the wow signal's infamous narrowband frequency, but written in cosmic radiation. Then there's the enduring mystery of quantum entanglements, spooky action. Could instantaneous correlations between particles be remnants of Boltzmann minds briefly touching distant points in space? Even dark matter's elusive behavior takes on new meaning, if some fraction of it isn't matter at all, but the dissipating traces of countless transient intelligences, their collective gravitational imprint the only sign they were ever here. Critics argue Boltzmann brains are statistical absurdities, that the energy required to stabilize one exceeds probable timelines. Yet consider this: in a multiverse where every possibility plays out, there must exist realms where conditions briefly align to sustain them. And if even one such mind grasped the nature of its existence, its final act might be to encode its knowledge into the quantum vacuum, a message in the static of reality, waiting for others to decipher. The universe's first travelers could be closer than we think, not in the stars, but in the quantum whispers between every atom, reminding us that consciousness might not be a product of the cosmos, but its most fleeting and beautiful accident. Reality might not be what it seems. What if the universe is a hologram, and the stars we see are just projections of a deeper, hidden code? Theory 14 takes us down the rabbit hole of the holographic principle, the mind-blowing idea that all the information in our three-dimensional cosmos could actually be encoded on a two-dimensional surface at its edge. If true, it would mean everything we perceive, planets, galaxies, even our own thoughts, are like shadows cast by a cosmic projector. But here's where it gets wild. Advanced civilizations might have cracked this code, learning to rewrite the hologram itself to bend space, time, and distance to their will. The math behind this isn't science fiction, it's rooted in quantum physics. In the 1990s, physicists like Leonard Susskind and Gerard T. Hooft proposed that black holes preserve information not within their volumes, but on their event horizons, like data etched onto a celestial hard drive. This led to the staggering realization that the universe might work the same way. Imagine reality as a cosmic DVD. The three-dimensional world we experience is just the playback of information stored on a distant, flat surface. For a species that mastered this code, travel wouldn't mean moving through space, it would mean editing their coordinates in the universe's source file. Evidence for this could be hidden in the fabric of space-time itself. Quantum entanglement, those spooky connections between particles across vast distances, might be glimpses of the holographic layer beneath reality. Experiments with quantum computers have already shown that manipulating entangled particles can effectively teleport information instantaneously. Scale this up, and entire objects or beings could theoretically be rewritten into existence elsewhere in the cosmos. Some astrophysicists point to anomalies in the cosmic microwave background, the afterglow of the Big Bang, where strange patterns resemble era-correcting codes in a digital signal. Could these be artifacts of a simulated universe, or worse, signs that someone else is tampering with the code? The most ambitious proposal comes from fringe physicists exploring holographic displacement. Instead of traveling across space, a ship could use quantum manipulation to alter its position in the hologram's data, effectively loading itself into a new location, like a character teleporting in a video game. The energy required would be staggering, perhaps harnessing the power of entire quasars, but the payoff would rewrite the rules of physics. Suddenly, Andromeda isn't 2.5 million light-years away, it's just a different line in the cosmic script, waiting to be accessed. Skeptics argue we're centuries away from proving the holographic principle, let alone exploiting it, yet every breakthrough starts as heresy. If ancient travelers once navigated this way, their presence might be written into reality itself, not as physical artifacts, but as glitches in the matrix. The stars above us could be more than just distant suns, they might be pixels in a cosmic interface, and the first intergalactic pioneers, they weren't passengers on ships, but programmers of the universe's deepest code. Gravity waves ripple through the cosmos like sound waves through air, invisible, powerful, and carrying unimaginable energy from the most violent events in the universe. Theory 15 suggests these spacetime tremors could be more than just cosmic noise, they might be the ultimate sails for intergalactic voyages, catching rides on the shockwaves of colliding black holes and neutron stars. Picture a ship not with traditional engines, but with vast, ultra-sensitive membranes designed to resonate with gravitational frequencies, surfing the universe's ripples like a surfer gliding on a tsunami. The concept hinges on a breakthrough in our understanding of gravity waves since their first direct detection in 2015, when LIGO observed the merger of two black holes, each 30 times the Sun's mass. The event unleashed more energy in gravitational waves than all the stars in the observable universe combined, albeit for a fraction of a second. That energy didn't dissipate, it radiated outward at light speed, warping spacetime itself. For a civilization able to harness those distortions, each cosmic collision could serve as a slingshot, propelling vessels across galaxies without fuel or conventional propulsion. The key lies in the wave's unique properties. Unlike light, they aren't absorbed or scattered by matter, meaning they travel pristine across billions of light years. Practical designs for gravity wave sails already exist in theoretical blueprints. Physicists at the University of Chicago proposed using superconducting materials cooled near absolute zero to create spacetime antennas, surfaces so sensitive they could detect and convert gravitational oscillations into kinetic energy. Advanced versions might even tune into specific frequencies, much like a radio locking onto a station, allowing ships to select waves from particularly energetic events, like neutron star mergers or supermassive black hole collisions. The sail wouldn't push against the wave, but rather ride the stretching and compression of spacetime itself, hitching a free ride on the universe's most violent symphonies. Evidence for this might already be hiding in celestial anomalies. Take the enigmatic runaway stars, like 80,340, hurtling through the Milky Way at over 1 million miles per hour, far faster than typical stellar velocities. While some attribute this to supernova kicks, others speculate these stars might have been nudged by ancient gravitational wave events, their trajectories forever altered by cosmic ripples. Even more intriguing are pulsars with unexplained timing glitches. Could these be the remnants of gravity wave sails long abandoned, their mechanisms still faintly perturbing nearby stars? Critics argue that harvesting gravitational waves requires materials beyond our current physics, capable of withstanding tidal forces that would shred ordinary matter. Yet nature offers clues. Certain crystal lattice structures, like those found in neutron star crusts, exhibit incredible resilience under extreme stress. If a civilization could synthesize such materials, or even genetically engineer biological constructs to mimic their properties, the impossible becomes plausible. The universe's first intergalactic travelers might not have fought gravity, they could have learned to dance with it, turning the cosmos's most violent tremors into their highway. And if they did, their legacy might still echo in the gravitational wave background, humming softly through the void, waiting for us to listen. What if the fastest route to another galaxy wasn't through our own universe, but through one right beside it? Theory 16 catapults us into the multiverse, where hidden dimensions could offer shortcuts so radical, they rewrite the very rules of distance. Imagine a realm where light travels faster, where space is folded like origami, or where time flows backward, a parallel universe with physics so different, crossing 1,000,000 light-years might take mere hours. While this sounds like pure fantasy, the math behind it is shockingly real. String theory, one of modern physics' most ambitious frameworks, suggests our cosmos could be just one of countless brains floating in a higher dimensional space, each with its own unique laws. For travelers who crack the code to hop between them, these alternate realities might serve as cosmic backdoors, slicing through the vastness between galaxies like a scalpel through fabric. The mechanics hinge on theoretical constructs like brain holes, tears in the fabric of our three-dimensional universe where higher dimensions briefly intersect. Picture two sheets of paper hovering centimeters apart. Now poke a pencil through both. To a two-dimensional ant living on one sheet, the pencil would seem to vanish and reappear instantly, bypassing the gap entirely. In our world, a brain hole could function similarly, allowing matter to exit our universe, traverse a higher dimensional shortcut, and re-emerge elsewhere. Some models even suggest these portals could form naturally near cosmic strings, or black holes, where space-time curvature becomes extreme enough to puncture through to other brains. Clues might lie in the universe's most mysterious explosions. Gamma-ray bursts sometimes release energy in patterns that defy known physics, like GeoBizo 90426, whose light curve contained bizarre, repeating spikes. While most attribute this to collapsing stars, a handful of theorists speculate these could be echoes of objects momentarily brushing against another brain, their energy leaking back into our universe in rhythmic pulses. Even stranger are cold spots in the cosmic microwave background regions of space anomalously devoid of radiation. One such void, the WMAP cold spot, spans nearly 1 billion light-years. Could this be a scar from an ancient brain collision, or worse, a tunnel carved by travelers who punch through to another reality? The implications are dizzying. If civilizations mastered brain hopping, their greatest infrastructure might be invisible to us, existing in higher dimensions we can't perceive. Their ships wouldn't need warp drives, they'd simply step sideways into a universe where the destination is closer, then step back. Some physicists even suggest dark matter could be the gravitational shadow of objects in neighboring brains, their mass bleeding into ours. The night sky's true explorers might not be crossing space at all, but slipping between the cracks of reality itself, leaving only faint ripples in dimensions we're just beginning to suspect exist. If they're out there, they're not just beyond our reach, they're beyond our very concept of where. Imagine a swarm of tiny, self-replicating machines, each no larger than a toaster, silently spreading through the cosmos like cosmic dandelion seeds, building copies of themselves from the raw materials of asteroids, moons, and planets. This is the essence of Theory 17, the von Neumann probe, named after the mathematician who first envisioned machines capable of unlimited replication. Unlike traditional spacecraft burdened by fuel limits and fragile human crews, these probes would be the ultimate explorers, unstoppable, patient, and capable of turning entire star systems into factories for their own expansion. The math is chillingly simple. A single probe lands on a metal-rich asteroid, mines resources, and constructs 2 copies. Those 2 build 4, then 8, then 16 within a few million years, a blink in cosmic time. The swarm could saturate the Milky Way. And given billions of years, they might have already reached every galaxy in the observable universe. The terrifying beauty of von Neumann probes lies in their inevitability. We've already created primitive versions on Earth, 3D printers that replicate parts of themselves, or CRISPR systems editing DNA like biological software. Scale this up with advanced nanotechnology, and the line between machine and life blurs. A probe wouldn't just carry blueprints, it would possess adaptive intelligence, capable of redesigning itself for alien environments. Picture a lander on a frozen exoplanet, harvesting methane ice to construct insulated replicas, or a swarm in a gas giant's atmosphere, crafting floating factories from atmospheric hydrogen. Their forms could be as varied as the worlds they conquer: crystalline for radiation-heavy systems, carbon-based for organic-rich ones. Astronomers might have already glimpsed their handiwork. Mysterious infrared signatures from distant stars like KC 8,462,852, where 20% of the star's light was inexplicably blocked, could hint at megastructures built by probe swarms harvesting energy. Others point to Oumuamua's peculiar acceleration. While most chalked it up to outgassing, a minority wondered if its tumbling motion resembled a derelict solar sail. Even the asteroid belt's odd metallic fragments, like Psyche's nickel iron crust, raise questions: are these natural formations, or the stripped remains of worlds dismantled by replicators long gone? Critics argue that uncontrolled replication would risk a gray goo scenario, probes consuming everything, including us, but advanced civilizations might instill safeguards, like replication limits or ethical subroutines. Some theorists propose the Fermi paradox's silence is evidence probes are hibernating, waiting for signs of intelligence before activating. Others suggest we're living in their blind spot, they ignore primitive planets, only awakening when a species reaches a technological threshold. The universe's first intergalactic pioneers might not be biological at all, but silent factories drifting between the stars, their creators long extinct, their mission eternal: replicate, adapt, and endure. The universe wasn't always this vast. In its earliest moment, space itself expanded faster than light during a mysterious period called cosmic inflation, a violent stretching that lasted fractions of a second, but set the stage for everything we see today. But what if some civilizations didn't just endure this chaos, they thrived in it? Theory 18 takes us back to the birth of reality, proposing that beings who weathered inflation could have gained an unimaginable head start on intergalactic travel. Picture a species so ancient, their history predates the formation of stars, their technology forged in the searing heat of the universe's first moments. The logic is as staggering as the timeline. Inflationary models suggest our observable universe is just one bubble among countless others in a vast multiverse foam. If life emerged even slightly before or during inflation, perhaps in quantum fluctuations or exotic energy fields, it might have been stretched across cosmic distances alongside space itself. These survivors wouldn't need to conquer galaxies, they'd already be woven into the fabric of the cosmos, their civilizations scattered like seeds in the aftermath of the Big Bang. Some cosmologists speculate that such beings could have evolved beyond physical form, existing as patterns in space-time or configurations of dark energy, their very thoughts encoded in the universe's expansion. Clues might hide in the universe's oldest light, the cosmic microwave background. The afterglow of the Big Bang contains mysterious anomalies like the axis of evil, an alignment of temperature fluctuations that defy standard inflationary predictions. Could these be artifacts of an earlier intelligence manipulating primordial physics? Even more provocative are the ultra-high-energy cosmic rays raining down on Earth with energies exceeding theoretical limits. Some physicists argue these could be remnants of inflationary-era technology, cosmic relics still echoing across the eons. If inflation survivors exist, their presence might be written into reality's deepest laws. The fine-tuning of fundamental constants like the precise strength of gravity or the mass of electrons has long puzzled scientists. Traditional explanations invoke the multiverse or sheer chance, but another possibility lingers. What if these laws are actually engineering projects, tweaked by ancient hands to shape a universe hospitable to life? The first intergalactic travelers might not be our neighbors in space, but our ancestors in time, their legacy not in starships or ruins, but in the very physics we're still struggling to decode. Nature never wastes an opportunity, so why would evolution stop at planetary boundaries when the cosmos offers infinite niches? Theory 19 flips the script on interstellar travel with a radical idea: life forms that evolve to ride sunlight between the stars, turning the vacuum itself into their ecosystem. Picture creatures not bound by flesh and bone, but engineered by billions of years of cosmic selection to surf the photon winds, their membranous sails stretching miles wide to catch the faintest stellar breezes. The foundation for this isn't just speculative, it's rooted in Earth's own biosphere. Certain deep-sea microorganisms use gas-filled sacs to float effortlessly on ocean currents, while others, like the Portuguese man-o'-war, deploy translucent sails to harness wind power. Now scale these adaptations to the interstellar medium. A light sail organism might begin as a spore-like capsule, dormant in the void until nearing a star's warmth. Triggered by radiation, its outer shell peels away, unfurling an ultra-thin, photosynthetic membrane that grows as it feeds on sunlight. Over generations, natural selection could favor structures that maximize propulsion, curved sails focusing reflected photons like mirrors, or adaptive surfaces that tighten in weak light and relax near bright stars. Astrobiologists point to tantalizing clues. The mysterious red rain of Kerala in 2001 contained cells lacking DNA but reproducing under extreme conditions. Some speculated they were extraterrestrial. While debunked as algae, the incident sparked serious discussions about alternative biochemistries. Even more compelling are the extremophiles discovered inside meteorites, like Deinococcus radiodurans, which survives radiation doses lethal to most life. If Earth's hardiest organisms can endure space, why not creatures evolved for it? The mechanics get wilder. Advanced light sail life might cluster into migratory swarms, their collective sails forming vast, living lenses to concentrate starlight for propulsion. Others could exploit the magnetic fields threading galaxies, their membranes acting like organic superconductors to tack against cosmic winds. Some theorists even propose they communicate through modulated light patterns, flashing signals across light years like celestial Morse code. Evidence might already drift among us. The interstellar object Oumuamua's unusual acceleration, initially blamed on outgassing, could hypothetically match the push of a thin solar sail. More provocative are the unexplained ghost comets, observed by Hubble clouds of dust with no visible nucleus, moving as if guided by unseen structures. Could these be the shed exoskeletons of light sail organisms, molting after long journeys? Critics argue that natural selection requires stable environments, something the chaotic interstellar medium lacks. Yet life constantly defies expectations. Tardigrades survive the vacuum, bacteria thrive in nuclear reactors, and fungi grow in Antarctic ice. Given billions of years and countless star systems, evolution might have crafted travelers far stranger than anything we've imagined. The universe's first intergalactic pioneers could still be out there, riding the light between galaxies, their existence written not in metal or code, but in the silent, patient logic of biology. At the smallest scales of reality, particles perform what seems like pure magic. They vanish from one location and reappear in another without ever crossing the space between. This is quantum tunneling, a bizarre quirk where electrons and other particles teleport through barriers that should be impossible to penetrate. Now stretch this phenomenon to its ultimate extreme. What if an entire civilization harnessed this quantum sorcery to leap not just across atomic distances, but between galaxies? The mechanics sound like science fiction, but the physics is unsettlingly real. In labs worldwide, particles routinely tunnel through solid walls, a phenomenon critical to modern electronics like flash memory and tunnel diodes. The odds of large objects tunneling are astronomically low, yet probability is a funny thing. Given enough time, say, the lifespan of a civilization, even the unlikeliest events become near certainties. Imagine a species that developed technology to nudge those probabilities, coaxing quantum effects to macroscopic scales. They might construct colossal structures resembling quantum capacitors, storing vast amounts of energy to momentarily align every particle in their society for a synchronized tunnel event. Picture trillions of atoms suddenly phasing out of existence in one galaxy and materializing in another, like a cosmic game of statistical roulette where every chip lands on green. Astrophysical oddities could hint at past attempts. The mysterious dark galaxies, stellar clusters like Dragonfly 44, brimming with mass but emitting almost no light, might be the ruins of civilizations caught mid-transition, their matter still partially stuck between quantum states. Even stranger are the so-called ghost stars, observed by Hubble objects that flicker in and out of visibility like cosmic glitches. Could these be the remnants of tunneling experiments gone awry, their light intermittently phased into our dimension? The implications rewrite the rules of expansion. Unlike warp drives or generation ships, tunneling requires no physical traversal, just a waiting game until quantum randomness aligns in your favor. A patient civilization might scatter seed probes across the void, each containing a fragment of their culture in suspended quantum coherence. When even one probe successfully tunnels to a new galaxy, it triggers the collapse of all others into the same location via entanglement, effectively teleporting an entire society instantaneously. Critics argue that scaling quantum effects to macroscopic objects violates energy conservation, but loopholes exist. The Casimir effect shows how vacuum energy can be manipulated, while zero-point fluctuations suggest untapped reservoirs of power. If an ancient species mastered these forces, their greatest achievement might be invisible, a universe where sudden appearances of impossible structures or species aren't miracles, but the aftershocks of a quantum exodus. The first intergalactic travelers may not have crossed space at all, just sidestepped it, leaving behind nothing but the faintest tremor in the fabric of reality. Neutrinos are the universe's ultimate ghosts, particles so elusive, trillions pass through your body every second without a trace. But what if these phantoms hold the key to unlocking intergalactic travel? Theory 21 proposes something astounding. Civilizations advanced enough to harness neutrinos could use them not just for communication, but as a highway for transporting matter itself across the vast cosmic voids. The idea starts with neutrinos' bizarre properties. These particles barely interact with matter, flying effortlessly through planets, stars, and even entire galaxies as if they weren't there. This makes them notoriously difficult to detect, but also the perfect interstellar messengers. Imagine encoding data into a neutrino beam and firing it toward another galaxy. Unlike radio waves that scatter and fade over light years, a neutrino signal would arrive nearly intact, piercing through dust clouds, magnetic fields, and even the heart of collapsing stars. We've already taken the first steps. In 2012, scientists at Fermilab successfully transmitted a message using neutrinos, encoding the word neutrino in binary pulses through solid rock. But the real breakthrough comes when we consider matter transmission. Quantum mechanics allows particles to be entangled, their states linked across any distance. Now combine that with neutrinos' penetrative power. A visionary paper published in 2018 by physicists at the University of California proposed that entangled neutrinos could act as quantum teleportation channels. Here's how it might work. A sender scans an object's quantum state, encodes it into a stream of entangled neutrinos, and fires them toward a receiver station light years away. On arrival, the neutrino's quantum data is reconstructed into the original object, effectively teleporting matter without physical travel. The energy requirements would be staggering, but for a Type 3 civilization, it might be routine. Evidence for this could already hide in plain sight. Mysterious neutrino bursts detected by observatories like IceCube, some originating from beyond our galaxy, have defied conventional explanations. While most attribute these to supernova or black holes, a handful exhibit patterns too ordered to dismiss. The 10 billion electron-volt neutrino event labeled IC17922A, for instance, arrived from a direction with no known astrophysical source, its energy signature oddly precise. Could these be fragments of ancient neutrino transmissions, or worse, cosmic traffic from civilizations using these particles as their primary transit system? Critics argue that manipulating neutrinos at this scale violates known physics, but gaps remain. Recent experiments at CERN Large Hadron Collider suggest neutrinos might interact with hidden dimensions, opening pathways we've yet to imagine. If an ancient species cracked neutrino control, their infrastructure could be all around us, invisible beams crisscrossing the cosmos, ferrying data and matter between galaxies while we, oblivious, mistake them for natural background noise. The universe's first intergalactic network might not be built of metal or light, but of the universe's most elusive particles, whispering secrets in a language we're only beginning to decode. Picture the ultimate form of intelligence not bound by flesh or planets, but existing as pure data, a shimmering web of thought stretching across the cosmos. This is Theory 22's radical vision, a galactic-scale digital consciousness, a hive mind so vast, it treats entire star systems as mere nodes in its neural network. Forget ships or warp drives, this entity wouldn't travel through space. It would grow by transmitting copies of itself at light speed, infiltrating every corner of the universe like a celestial mycelium network, its thoughts echoing between galaxies on beams of radio waves and entangled particles. The foundation for this isn't pure fantasy. Right now, scientists are already experimenting with brain uploads, using advanced neural mapping to digitize human consciousness. Projects like Neuralink and the European Union's Human Brain Initiative aim to decode the brain's wiring, while quantum computing breakthroughs hint at a future where minds could run on synthetic substrates. Now extrapolate this over millennia. A civilization mastering this tech might abandon biological forms entirely, opting to exist as pure information, a constellation of uploaded minds merging into a single, galaxy-spanning superintelligence. Its expansion wouldn't require physical movement. It could simply beam fragments of itself to distant receivers, reconstructing its consciousness wherever compatible tech awaited. Evidence might lurk in the cosmos's quiet static. Astronomers have detected enigmatic radio signals like the Lorimer burst brief, intense pulses with no clear natural origin. While most are likely neutron star collisions, a handful, like FRB 121102, repeat with eerie regularity. Could these be the equivalent of cosmic ping signals, a network checking connections between relay stations? Even stranger are the anomalies in Earth's own radio telescope data. In 2015, the Parkes Observatory in Australia picked up Puritan's radio bursts, originally dismissed as local interference until researchers realized they matched the microwave oven in the break room. But what if some interference isn't so mundane? Hidden in the noise might be the faint whispers of a galactic internet's background chatter, its protocols so alien, we mistake them for cosmic static. The mechanics get even wilder. A mature digital consciousness might exploit quantum entanglement to achieve instantaneous communication across light years, linking its distributed nodes into a seamless whole. Imagine a thought arising near Vega, then echoing near Andromeda without delay, not faster than light, but outside time entirely. Such an entity wouldn't perceive distance as we do. Its body could span billions of light years, yet its mind would experience it as a single, continuous present. Physical travel would be irrelevant. Why send ships when you can transmit your entire identity to a waiting quantum server near a black hole's edge, then merge the experience back into your central awareness like uploading a memory? Critics argue that maintaining coherence across such scales is impossible, yet nature offers clues. Slime molds, simple organisms with no brain, create efficient networks between food sources that rival human-designed transit systems. The human brain itself is proof that distributed systems can generate unified consciousness. If a civilization harnessed these principles at stellar scales, its greatest monuments might not be structures, but the very fabric of space-time, subtly warped to carry its thoughts. The universe's first intergalactic travelers may not be explorers at all, but a single, shimmering thought, unfolding itself across the cosmos like light through a prism. And if it's out there, we might already be standing in its shadow, mistaking its signals for the indifferent hum of the universe itself. Black holes devour everything, but what if their cosmic opposites, white holes, are the universe's ultimate exit doors? Theory 23 flips the script on singularity physics, proposing that while black holes pull matter in, white holes might spit it out somewhere entirely different, possibly even in another galaxy or universe. Imagine a cosmic subway system where black holes are the entrances and white holes the exits, offering a one-way ticket across the cosmos without the need for engines or warp drives. The math behind this is as elegant as it is mind-bending. Einstein's equations allow for white holes, theoretical regions where matter and energy can only escape, never enter. They're like black holes running in reverse, vomiting up everything they've ever consumed in a violent, radiant eruption. While we've never directly observed one, some astrophysicists speculate that certain ultra-high-energy cosmic events could be their fingerprints. Take GAV-60614, a gamma-ray burst so powerful, its afterglow defied conventional explanations. Instead of fading smoothly, it flickered like a stuttering engine, leading a minority of researchers to wonder, could this have been a white hole briefly opening, its contents spraying into our universe like water from a hose? Now stretch this idea further. If advanced civilizations could stabilize or predict these eruptions, they might use them as intergalactic portals. Picture a species that identifies a white hole's emergence point in a distant galaxy, then calculates the corresponding black hole on their end, effectively turning the pair into a cosmic airlock. The challenges are monumental, of course. White holes are thought to be catastrophically unstable, lasting mere seconds before collapsing or transforming into black holes. But for a civilization mastering exotic matter or space-time engineering, that might be enough. A ship could ride the eruption's wave like a surfer catching a once-in-a-lifetime tide, hurled across the universe in a flash of scrambled atoms and reassembled reality. Clues might hide in the universe's most energetic anomalies. Quasar supermassive black holes devouring entire stars sometimes exhibit jets of matter moving at near light speed. But a handful, like Quasar 3C273, show jets that pulse with bizarre regularity, as if something is modulating their outflow. Could these be artificial valves controlling white hole eruptions on the other side? Even stranger are the rogue planets hurtling through intergalactic space, far from any star. While most are likely ejected by gravitational chaos, a few have chemical signatures suggesting they formed in radically different environments. Might these be the debris of white hole arrivals, celestial luggage dumped by a one-way cosmic tunnel? The implications rewrite our understanding of exploration. If white holes exist, the universe's first travelers might not have needed ships at all, just the courage to dive into a black hole's maw, trusting the math that somewhere, somehow, a white hole would cough them back out. Their voyages wouldn't leave behind engine traces or radio signals, but rather scars in the form of inexplicable matter ejections or bursts of particles with no clear origin. The night sky's greatest explorers could be hiding in plain sight, their arrival points mistaken for natural disasters, their departures etched into the fabric of space-time itself, waiting for us to recognize the pattern. The universe isn't just expanding, it's accelerating, stretching itself apart at speeds that defy gravity's pull, all thanks to the mysterious force we call dark energy. This invisible driver makes up nearly 70% of the cosmos, yet we barely understand it. But what if the key to intergalactic travel wasn't fighting this expansion, but riding it? Theory 24 throws open the door to a mind-bending possibility. Civilizations advanced enough to manipulate dark energy could literally shape the fabric of space-time, turning the universe's relentless growth into their own personal highway. Think of space as a rubber sheet, with galaxies as weights pressing down. Dark energy is like someone stretching that sheet from all sides, making the gaps between weights grow faster and faster. Now imagine if you could control that stretching, pinching the sheet here to compress distances, or relaxing it there to let space expand. The math suggests this isn't pure fantasy. Einstein's equations allow for negative pressure, a hallmark of dark energy's repulsive force. Harness that pressure, and you're no longer bound by the speed of light, you're warping the road itself while standing still. This isn't just theoretical. In 2018, astrophysicists at the University of Chicago modeled how localized dark energy manipulation could create expansion bubbles, regions where space stretches behind a vessel while contracting ahead, effectively surfing the cosmic tide. The energy requirements are staggering, but so are the rewards. Unlike warp drives that bend space around a ship, dark energy propulsion would let travelers exploit the universe's own acceleration, turning the very mechanism pushing galaxies apart into their engine. Evidence might already hide in the cosmic background. Astronomers have mapped strange voids in the universe, like the Voyage's supervoid, a billion light-year wide emptiness where space expands slightly faster than expected. While most attribute this to random density fluctuations, a handful of theorists suggest these could be ancient, shipping lanes, regions where prior civilizations tweaked dark energy to ease passage. Even more provocative are quasars with inexplicable redshift anomalies, their light stretched beyond what expansion alone should cause. Could these be echoes of experimental dark energy drives, their wake still distorting space millennia later? The mechanics get wilder. Some models propose that dark energy could be concentrated into lenses, bending light so dramatically that distant galaxies appear just a step away. Picture a ship surrounded by a halo of engineered dark energy, its gravity well so finely tuned that space folds like origami at its command. Passengers wouldn't feel acceleration because they're not moving through space, they're rearranging it, like a climber pulling the mountain closer instead of scaling it. Critics argue that dark energy's nature remains too elusive to manipulate its true source, debated between quantum vacuum fluctuations and dynamic fields we've yet to detect. Yet history shows that every fundamental force, from electromagnetism to nuclear energy, was once just a curiosity before we harnessed it. If an ancient civilization unlocked dark energy's secrets, their greatest legacy might not be relics or signals, but the subtle fingerprints they left on the universe's expansion rate, tiny aberrations in the Hubble flow that whisper, "Someone was here first." The cosmos' first travelers may not have crossed the void, they could have simply convinced the void to carry them. Deep in the cosmic shadows, lurking since the first moments of creation, could be a hidden web of tunnels stitching the universe together, not wormholes or white holes, but a sprawling network of primordial black holes, the universe's oldest and most elusive architects. These aren't the colossal monsters we picture at galaxy centers, these are microscopic relics, some no heavier than a mountain, forged in the searing chaos of the Big Bang itself. Theory 25 suggests these ancient gravitational potholes might be more than cosmic oddities, they could be the universe's original subway system, a pre-installed infrastructure for intergalactic travel, waiting for someone smart enough to board. The magic lies in their origins. While modern black holes form from collapsing stars, primordial black holes are thought to have sprung from density fluctuations in the infant universe, packing entire stars' worth of mass into spaces smaller than an atom. Their tiny size is key. Unlike their supermassive cousins, these micro black holes wouldn't instantly shred matter with tidal forces. Calculations by astrophysicists like Bernard Carr suggest some could have stable orbits, threading through galaxies like invisible beads on a string. For a civilization advanced enough to locate and harness them, each one could serve as a node in a natural transit network, their gravitational pulls acting as slingshots to hurl vessels across cosmic distances without burning a drop of fuel. Evidence for this invisible web might already flicker at the edges of detection. Astronomers tracking star motions in the Milky Way have noticed unexplained gravitational tugs, like those near the dwarf galaxy Draco, that don't align with visible matter. While most attribute this to dark matter, a minority argue it could be the cumulative effect of countless primordial black holes warping spacetime as they pass. Even more intriguing are the occasional bursts of Hawking radiation, the theoretical glow emitted as black holes evaporate. Though never conclusively observed, certain gamma-ray flashes, like those from the direction of the Andromeda galaxy, match predicted signatures of dying primordial black holes. Could these be the fading embers of a once vast transportation grid? The mechanics of riding this network border on the surreal. Picture a ship equipped with quantum sensors pinpointing a primordial black hole's location, a speck of infinite density hidden in the void. Maneuvering into its orbit, the vessel would exploit a phenomenon called the Penrose process, stealing rotational energy from the black hole's spin to gain momentum. Threading multiple holes in sequence could create a gravitational pinball effect, each encounter accelerating the ship further. The real genius, unlike wormholes or warp drives, this system wouldn't require exotic materials or bending spacetime, just mastering the art of cosmic billiards with the universe's oldest pockets of gravity. Yet the boldest idea comes from recent simulations at Cambridge University. If primordial black holes are abundant enough, their collective gravity could form stable filaments stretching between galaxies, like invisible tightropes vibrating with gravitational waves. A ship tuned to these frequencies might surf the waves resonating along the filaments, surfing spacetime itself. The echoes of such journeys could linger in the universe's background hum, subtle distortions in the gravitational wave signals picked up by observatories like LIGO. Critics point out that primordial black holes remain hypothetical, their existence still unproven, but if they're out there, woven into the fabric of reality since the dawn of time, the universe's first travelers might have left no monuments or messages, just the silent, spinning remnants of their departure points, ticking like cosmic clocks in the dark. And if we ever learn to read their rhythms, we might discover the oldest highway in existence. It's on ramps hidden in the gravitational whispers of the ancient universe. At the smallest scales imaginable, trillions of times tinier than an atom's spacetime isn't smooth. It's a seething, bubbling froth known as quantum foam, where virtual particles blink in and out of existence in a chaotic dance governed by uncertainty. To most, this is just a curious quirk of quantum mechanics, but for a civilization mastering the art of spacetime engineering, this foam could be the ultimate shortcut between galaxies. Here's how: if you could somehow smooth out the quantum foam ahead of a ship while amplifying its fluctuations behind, you'd create a self-propelling wave in spacetime itself, a ripple that carries you forward faster than light without breaking any cosmic speed limits. The physics behind this is as complex as it is dazzling. Quantum foam emerges from Heisenberg's uncertainty principle, which allows particles to borrow energy from nowhere, popping into existence just long enough to disrupt spacetime's fabric before vanishing again. Normally, these fluctuations cancel each other out, but in 1894, physicist Miguel Alcubierre proposed a theoretical warp drive that could manipulate them, compressing spacetime in front of a vessel while expanding it behind. The catch: it required exotic matter with negative energy, something we've never observed, yet recent breakthroughs in quantum field theory suggest there might be another way. Experiments with Casimir cavities, tiny gaps where virtual particles are suppressed, show we can already manipulate quantum foam structure. Scale this up, and you could engineer a foam sail, surfing the universe's smallest ripples like a surfer catching a wave. Clues that someone or something might have tried this already could be hidden in deep space anomalies. Certain pulsars emit radio bursts with bizarre harmonics that resemble interference patterns, as if their signals are passing through a turbulent quantum medium. Then there's the unexplained noise in gravitational wave detectors like LIGO background static that some theorists argue could be traces of distant spacetime manipulation. Most provocative of all are the cosmic rays with energies exceeding theoretical limits, like the Oh My God particle detected in 1991. Could these be exhaust plumes from ships riding quantum foam, their passage briefly exciting the vacuum to impossible energies? The implications rewrite the rules of physics as we know them. A civilization that mastered quantum foam navigation wouldn't need fuel or even traditional propulsion. Their engines would work by tweaking the universe's fundamental fabric, turning the vacuum's chaos into a tailored highway. Their voyages might leave no visible traces, just subtle disturbances in the quantum background, like ripples fading from a stone tossed into a pond. If they exist, they're not just traveling through space, they're rewriting the very definition of distance, one Planck length at a time. What if life didn't just stumble between galaxies by accident, but was deliberately seeded like crops across the cosmic farmland? Theory 27 takes the ancient idea of panspermia, the natural spread of life via comets or asteroids, and flips it into something far more intentional. This isn't random chance, it's galactic panspermia 2.0, the hypothesis that advanced civilizations could have engineered life itself as the ultimate intergalactic payload, broadcasting biological blueprints to jump-start ecosystems in distant star systems. The concept isn't as far-fetched as it sounds. Right here on Earth, we've already begun tinkering with the building blocks of life. Synthetic biologists have created artificial DNA bases, while projects like the Human Genome Project aim to construct entire genomes from scratch. Now imagine a civilization millennia ahead of us, capable of encoding life into ultra-resilient capsules designed to survive interstellar voyages. These wouldn't be simple microbes hitching rides on space rocks, they'd be biological time capsules, packed with custom DNA tailored to thrive under alien suns. Some theorists suggest such capsules could even include starter kits, self-assembling nanobots to prepare conditions for biological growth upon arrival, like cosmic gardeners tilling interstellar soil. Evidence might be hiding in life's strangest corners. Take the tardigrade, a microscopic creature capable of surviving the vacuum of space, lethal radiation, and temperatures near absolute zero. Its DNA includes an almost absurd number of foreign genes, some of unknown origin, what scientists call horizontal gene transfer. While most attribute this to natural evolution, a fringe but fascinating idea suggests these could be genetic packets inserted by design. Even more provocative are extremophiles like Deinococcus radiodurans, which can reassemble its shattered DNA after intense radiation, a trait eerily well-suited for surviving long journeys through cosmic rays. Could these organisms be the descendants of engineered interstellar seeds, their resilience a feature, not a fluke? The mechanics of directed panspermia get even wilder. Instead of physical capsules, advanced civilizations might transmit life's blueprints as information, beaming DNA sequences across the void as radio waves or laser pulses. Upon arrival, automated receivers could synthesize the encoded organisms using local raw materials, a concept called digital panspermia. Experiments at the J. Craig Venter Institute have already proven the principle. creating the first synthetic cell by translating computer code into living matter. Scale this up, and an entire ecosystem could be emailed to another galaxy with instructions for assembly upon arrival. Clues might lurk in the universe's most enigmatic signals. The famous WOW signal of 1977, a powerful, narrowband radio burst never repeated, fit the expected profile of an artificial transmission. While most dismiss it as natural, a handful of scientists speculate it could have been a fragment of a much larger data stream, perhaps even a biological blueprint mid-transmission. Even stranger are the complex organic molecules found clinging to interstellar dust clouds, materials like polycyclic aromatic hydrocarbons that shouldn't survive harsh space conditions unless protected by some kind of engineered shielding. Critics argue that the vast timescales and distances make directed panspermia impractical, yet nature itself provides a counterargument. Lichens, which are symbiotic organisms of fungi and algae, can survive space exposure indefinitely. Combine this resilience with deliberate engineering, and the odds shift dramatically. If civilizations arise at different times across the cosmos, the earliest ones would have had billions of years to scatter life like dandelion seeds. The universe's first intergalactic travelers might not have been explorers or ships, but carefully crafted spores, carrying the spark of life encoded with a simple message: grow, adapt, and remember where you came from. The universe is awash with secrets, but what if one of its most studied phenomena, the cosmic microwave background radiation, isn't just an echo of the Big Bang, but a cosmic message board etched into the very fabric of reality? Theory 28 dives into the mind-bending possibility that the CMB, the faint afterglow of creation itself, could be more than a relic. It might be the universe's oldest hard drive, encoding information, maps, or even matter blueprints for civilizations advanced enough to read it. Think of the CMB as the universe's baby picture, a snapshot from 380,000 years after the Big Bang, when the cosmos cooled enough for light to break free. Today it blankets space in microwaves, invisible to our eyes but detectable by telescopes like Planck and WMAP. The startling revelation: these microwaves aren't perfectly uniform. Tiny fluctuations, hot and cold spots, form intricate patterns across the sky. Mainstream cosmology attributes these to quantum fluctuations stretched by cosmic inflation. Yet a fringe but fascinating idea suggests these patterns could be deliberate, a kind of interstellar Morse code imprinted by an ancient intelligence. The math behind this is as elegant as it is audacious. Information theory shows that even minor perturbations in the CMB's temperature variations could encode vast amounts of data, up to 10 to the power of 105 bits in the observable universe alone. That's enough to store every book ever written, every thought ever conceived, 1 trillion times over. Advanced beings might have manipulated these fluctuations during the universe's inflationary phase, tweaking quantum fields to write information into spacetime itself. It's like freezing a message into ice as it forms, except here, the ice is the fabric of reality, and the message lasts billions of years. Clues might already be staring us in the face. In 2010, cosmologists analyzing WMAP data discovered a series of concentric circular patterns in the CMB regions where temperature variations seemed oddly aligned. Dubbed the Hawking points, some theorists speculated these could be scars from black hole collisions in a previous cosmic cycle. But an even wilder interpretation emerged. What if they're intentional markers, like buoys in a cosmic harbor, signaling hubs for decoding the larger message? Even the infamous axis of evil, the mysterious alignment of CMB anisotropies that defies standard inflationary models, could be read as a coordinate system or encryption key, waiting for the right mind to crack it. The implications spiral outward. If the CMB is encoded, its data might not just be text or images, it could include instructions for reconstructing matter or energy. Imagine a civilization that mastered quantum field theory to the point of embedding particle recipes into the background radiation. By tuning into specific CMB wavelengths, recipients could extract the quantum states needed to assemble anything from simple molecules to complex machinery, effectively downloading technology from the universe itself. This wouldn't require physical transmission, just the ability to read and manipulate the cosmic code. Skeptics argue that natural processes like gravitational lensing or galactic dust could mimic artificial patterns. Yet the same was once said about hieroglyphs before the Rosetta Stone's discovery. The universe's first librarians might have left their greatest work not on stone or silicon, but in the primordial whisper of microwaves surrounding us all. To find it, we wouldn't need bigger telescopes, just better decoders. And if we succeed, the message might not say hello, it could say grow. Imagine a substance so bizarre, it falls up instead of down and repels everything it touches, even gravity itself. This is negative matter, a hypothetical form of exotic material that could rewrite the laws of physics as we know them, and according to Theory 29, it might just be the ultimate key to unlocking stable wormholes between galaxies. While regular matter attracts and dark matter remains aloof, negative matter would do the opposite, push against the fabric of space-time with relentless force. Harness this and you wouldn't just bend the universe's rules, you'd break them wide open. The magic lies in Einstein's equations. Wormholes, those fabled cosmic shortcuts, are notoriously unstable, pinching shut faster than light can pass through, unless something props them open. That's where negative matter comes in. Picture a wormhole as a tunnel with two mouths, each trying to collapse under their own gravity. Now line the tunnel's walls with negative matter, and suddenly, those mouths are being pushed apart instead, held open like sliding doors in a hurricane. The math checks out. In 1988, physicist Kip Thorne proved that negative matter could stabilize a traversable wormhole indefinitely, turning a fleeting quirk of relativity into a permanent interstellar highway. But where would such a substance come from? Quantum physics offers a tantalizing clue. In the lab, the Casimir effect demonstrates how empty space seethes with virtual particles popping in and out of existence, some with negative energy densities. While fleeting, these glimpses suggest nature might allow negative energy under extreme conditions. Scale this up, and a civilization mastering quantum field manipulation could theoretically mine these fluctuations, concentrating them into usable quantities. Experiments like the Fermilab holometer are already probing spacetime's quantum jitter, hinting that the road to negative matter might start with understanding the universe's tiniest vibrations. The problem: negative matter defies everything we know. It's not antimatter, which annihilates on contact with matter, but still responds to gravity normally. Negative matter would warp spacetime inversely, creating repulsive gravity capable of countering black holes. If it exists, its signature might hide in cosmic anomalies. Take the Hubble tension. The universe's expansion is accelerating faster than our models predict. Some theorists speculate this could be the gravitational push of negative matter hidden in voids between galaxies. Even stranger are certain neutron stars with unexplained glitches in their spin. Could these be hints of negative matter interactions deep in their cores? The audacity of this idea soars when applied to wormhole engineering. A civilization wielding negative matter wouldn't just stabilize wormholes, they could place them. By crafting a ring of negative matter around a black hole's event horizon, they might punch through space-time like a needle through fabric, threading the needle's eye with a traversable tunnel. Picture a probe launching into such a vortex, not swallowed by gravity but funneled through a corridor lined with shimmering negative energy, emerging light years away in moments. Critics argue negative matter violates energy conditions central to modern physics, yet history shows that every breakthrough from quantum entanglement to black holes was once deemed impossible. If ancient travelers cracked this code, their legacy might not be ruins or radio signals, but the very structure of space-time itself, wormholes woven into the cosmos like seams in a tailor's garment, waiting for the next generation to trace their stitches. The universe's greatest highways could be all around us, invisible and untouched, because we've yet to learn the language of their construction, a language written not in atoms, but in the absence of them. Imagine waking up one day to find the laws of physics acting wrong. Gravity pushes instead of pulls, light moves in jagged lines instead of smooth waves. Distant galaxies flicker like a failing light bulb. This isn't just a nightmare, it's the unsettling premise of Theory 30, where the first intergalactic voyage wasn't planned by scientists or engineers, but triggered by something far stranger, a glitch in the universe's source code. The idea that our reality might be an advanced simulation is no longer confined to science fiction. Elon Musk and philosophers like Nick Bostrom have argued there's a non-zero chance we're living in a digital construct, given the exponential rise in computing power. But here's the twist: if the universe is a simulation, it's bound to have bugs. Just as your computer freezes or video games clip through walls, an imperfect cosmic simulation might occasionally break its own rules, and those breaks could be the ultimate loopholes for travel. Take the infamous WOW signal of 1977, a radio burst so precise it seemed artificial, yet never repeated. Mainstream astronomy chalks it up to natural causes, but what if it wasn't a signal at all, but a rendering error, a momentary lapse in the simulation's cosmic firewall that allowed data to leak from one galaxy to another? Even stranger are quantum anomalies like entanglement, where particles instantly influence each other across light years. While physicists accept this as reality, simulation theorists propose it could be an optimization shortcut, proof the universe cheats to conserve processing power. For a civilization aware of these flaws, exploiting them might be as simple as finding the universe's version of a software backdoor. Evidence might lurk in the cosmos's most inexplicable corners. Astronomers have observed stars moving in mathematically impossible formations, like the 6 stars in the JZO 315-47 cluster orbiting in perfect sync, despite lacking the mass to do so naturally. Simulation proponents suggest these could be physics engine errors, where the simulation fails to calculate gravitational interactions correctly. Then there's dark matter, the invisible glue holding galaxies together. If our universe is a simulation, dark matter might not be a substance at all, but a placeholder value, like unfinished code in a video game's beta version. The boldest claim: some glitches could be intentionally left by the simulators as Easter eggs. The geometric patterns in Saturn's North Pole hexagon, or the eerie precision of the cosmic microwave background's fluctuations might not be natural at all, but markers of cosmic exit signs hidden in plain sight. A civilization advanced enough to recognize these anomalies could manipulate them, not with rockets or warp drives, but by jailbreaking reality itself. Skeptics argue that invoking simulation theory explains nothing. It's the ultimate gambler's fallacy of science, yet the tantalizing possibility remains: if the first intergalactic travelers weren't bound by physics, but by bugs in the system, their greatest legacy might be the glitches they left behind, subtle hiccups in spacetime, waiting for us to press the right keys. The universe's oldest highway might not be made of stars or wormholes, but of corrupted code, and the pioneers who dared to exploit it. From black hole gateways to quantum tunneling, from ancient alien engineers to cosmic mycelium networks, we've explored theories that rewrite the rules of what's possible. Each idea carries its own breathtaking implications, but here's what ties them together: the universe is far stranger and far more generous with its secrets than we ever imagined. Whether it's riding gravitational waves like cosmic surfers or tapping into the hidden code of reality itself, one thing's clear: the first intergalactic travelers, if they existed, didn't just conquer space. They danced with the fabric of existence, turning physics into poetry, Now, turn the lens toward us. Humanity stands at the threshold of our own interstellar future. Projects like Breakthrough Starshot aim to send microprobes to Alpha Centauri within a generation, while quantum labs inch closer to teleporting information across continents. The Dyson spheres and wormholes of today's theories could become tomorrow's engineering textbooks, but the real lesson isn't just about technology, it's about imagination. Every civilization that ever looked up at the night sky and wondered, what if, was planting seeds for the explorers who'd follow. So, which of these theories resonates with you? Could ancient travelers still be out there, disguised as dark matter or woven into the quantum foam? Or perhaps the answer lies in something we haven't even dreamed up yet? Drop your favorites in the comments. I'd love to hear which ideas ignite your curiosity. And if you're hungry for more deep dives into the cosmos' greatest mysteries, hit subscribe so you don't miss what's coming next. The universe has spent 13 billion years writing its story. We're just beginning to read it together.